how many people get the joke in this slide? Does anybody get this? It's like amen, basically. OK. ENSIME, the joke is basically playing on the fact that ENSIME is not a new concept. OK? ENSIME is based on a concept that was developed for Slime, basically. So Slime is a common Lisp editing mode, common Lisp IDE mode, basically, for Emacs. And it's most recently gained a lot of traction as a mode for Clojure. So what Slime basically does, and what ENSIME does, is they provide IDE-like functionality in a subprocess controlled by your parent editor. And the editor communicates with them back and forth via a protocol. And they never block each other. And you basically have your regular text editor enriched with IDE-like functionality. So it's like 80 to 85% of an IDE, 80 to 85% of your Eclipse IDE, right, your monolithic craziness, but tucked into a really nice text editor package, right? Your Emacs editor or your Vim editor or whatever you happen to be working with. And there's a lot of really lovely things that come out of this. I mean, number one, you can continue to use Emacs and you don't have to use fake key binding packages. But more importantly, it is a totally optional workflow. Okay? This is something that a lot of people miss with things like ENSIME and Slime and things like that. And this is the thing that is compelling to me. When I'm using my editor, which is JEdit, okay, I can open up a Scala file that's not in a project that ENSIME knows about, that's maybe on a remote server. I'm loading it over some FTP connection or something like that, or maybe I just downloaded a gist. Maybe it's not even well-formatted Scala. I open it up in my editor, and it works in my editor. OK, I know that doesn't sound very impressive, but try doing that in Eclipse just once, because it's just a nightmare to try to make that work. Try doing it in IntelliJ. It's terrible. So it works because JEdit is a text editor. And ENSIME doesn't impose itself on my text editing life. ENSIME does its thing when I ask it to. So this is very, very, very powerful. So this is for me probably the main motivation for ENSIME. But there's another really important motivation here that is best summed up by a single image. This is steady state. Eclipse in this image has 3 files open. JEdit has 35. So 892 megs of RAM versus 318 megs of RAM. And Eclipse is sitting there using 10% of my CPU while it's doing nothing. This is crazy, OK? And ENSIME doesn't entirely solve this problem, but it hides it away. It tucks it away in such a way that the operating system is able to manage it better. And we're going to talk about this in a second. So IDEs, OK? Why are we doing this if we already have modern IDEs? It's not 2008 anymore. Eclipse actually works. IntelliJ is out there, and it's functional for Scala and things like that. But the fact is that IDEs are bad editors. IDEs have always been bad editors. And why is it that they're bad editors? Well, they give you everything you don't need, and about 70% of the things that you do. Okay? They were not designed to be primarily text editors. And the thing about our job, the thing about programming, is that most of what we're doing is manipulating text. And you can make the argument that text is just an abstraction for getting at the AST, and that's true. But it's the abstraction we work with. It's the abstraction we have. And so our tools should primarily optimize for manipulating text. That's the primary thing we do. That's the thing we're doing almost all the time. And the semantically aware stuff needs to be secondary. IDEs get this reversed. And they give us semantically aware editing and AST manipulation tools wrapped up inside of really, really, really primitive text editors. And this is backwards. This is entirely backwards. So there are text editors out there that do text editing fairly well. I mean, basically, any decent editor is going to give you the tools to be productive in text editing. Why not start with those and then enrich them with functionality? IDEs are also, I mean, this is another point that's often missed. IDEs are extremely confining. They are extensible. I mean, Eclipse is certainly much more extensible than it used to be. NetBeans is much more extensible than it used to be. But they, try adding support for a new language to Eclipse, and then come back to me and tell me that they're extensible. It's terrible. It's a nightmare. I add support for a new language to JEdit every week, and it takes me 5 minutes. Like, I can't imagine doing that in an IDE. So this is very, very important. So actions speak louder than words, and I think screencasts speak louder than actions. So here's a screencast showing ENSIME in action inside JEdit. I'm using JEdit because this is just my editor of choice, right? ENSIME was built specifically to work with Emacs, but it is editor agnostic, which is a point I'm going to hammer home later. So basically what I'm doing here is I am starting the ENSIME instance as a sub-process underneath JEdit. I was using JEdit prior to this without ENSIME and was only missing it for the things that ENSIME provides me, right? JEdit's functionality is not compromised by not having ENSIME ready. And what's happening here is ENSIME is giving us some status messages down in this bar at the bottom. I know it's kind of hard to see. Increasing this font size for JEdit is actually a bit of a pain. But that bar at the bottom there, that status bar, is where everything is going to show up. So one of the features that I'm going to demo here as soon as ENSIME is ready is things like finding the inferred type of a particular value, which I think is a very, very important thing for any Scala IDE or any IDE for a functional language to provide. And that inferred type is going to pop up at the bottom there. Basically, anything ENSIME wants to tell us is going to show up there. At the moment, we are waiting for ENSIME to say full type check finished. And this took a little longer than usual because ENSIME has performance issues on anti-XML. So here we go. The type of the node's value is vector case. Vector case is a class. We can find the inferred type of functions as well as variables, right? The type is int. See that down at the bottom there? We can do jump to declaration. Since we just put the cursor over node and use the appropriate key binding, we can jump into not only declaration of values, but also the declaration of classes. So this is like your control click from Eclipse. Very, very straightforward. This is amazing. Error highlighting on save. If your editor doesn't have this, you're wasting about 90% of your day. This is a huge productivity boost. And notice, it was literally instantaneous. My finger wasn't even off the S key, saving that, by the time that error message showed up. It can find type errors as well as name binding errors. It doesn't find everything because this is using the presentation compiler, but it finds a ridiculous number of things. And it finds them fast, which is the thing that matters. Here I'm using jump to type. Okay, this is your command shift T from Eclipse. And ENSIME's implementation of this is astonishingly crude, but actually works much better than Eclipse's, which I'm not sure how that works. What I just demonstrated there was syntax-aware selection. So I was like expanding the selection. Here I'm doing a rename. Okay, everybody loves refactorings, and I can do this on locals by just delegating to ENSIME. ENSIME gives me this refactoring support inside of my text editor. Another thing, but it's not just renames refactorings, right? It gives us basically anything that Scala refactoring offers. So I'm going to do jump into a member here. And then down here, what I'm going to do is I'm going to take the right member of that tuple that I'm returning, the new group right, and I'm going to extract local on this. I'm going to extract it into right group. Okay? Sort of thinks about it for a little bit, and then tells us the refactoring is complete. So we save, and there's an error, because ENSIME doesn't always get everything right. And I think this is actually Scala refactoring's fault. But this is a bug. You just delete the parentheses, and life is good again. So yeah, basically, this is a small fragment of the functionality that ENSIME actually does. This is a small fragment of the functionality implemented in JEdit. ENSIME provides even more things that I don't implement in JEdit, like content assist, right, where you're typing, dot, and then you get your helpful IntelliSense assistant that tells you what functions are available on a particular type. So this is all very, very useful stuff. And this helps me a tremendous bit in my workday. So what sort of features are there in here altogether? Well, we already saw inferred type. We saw jump to declaration. We saw fast type checking on save. Really, really, really fast. And anecdote that I want to emphasize here. When I started working on ENSIME in JEdit, I had 2 features that I wanted to do. Okay? Literally just 2 features that I wanted to enable. And it was worth learning ENSIME to do this. I wanted inferred type, and I wanted jump to declaration. Error highlighting is so easy to enable in JEdit that I just did it with 1 line of code because, it's an extra feature, and why not? And after I turned this on, and I reloaded the plugin, my productivity jumped by a factor of 3. So that's pretty awesome. I was totally not expecting that. This is really, 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 really helpful and worth fighting for to get this in your editor. ENSIME gives you refactoring. It's not the full set of Java refactorings, but it's certainly the full set of refactorings that are enabled inside of Eclipse and the full set of refactorings enabled inside of IntelliJ. So yeah, like I said, 80% of an IDE. We've got content assist, and there's even more. Okay, there's more stuff that we provide, or there's more stuff that ENSIME provides, some of which I provide. There's debugging. Everybody loves their debuggers. ENSIME has had this for a very long time in an essentially primitive and annoying form. Eamon has been working on this for the last couple months to improve this substantially to the point where the debugging support in ENSIME is really going to be a peer for what you have in Eclipse and IntelliJ and in other editors, in other IDEs. There's semantic highlighting. Eclipse still doesn't have this. I've been bugging Miles about this for 3 years, and Eclipse still doesn't have this feature. Eamon implemented it in like a weekend. So that's pretty ridiculous. JEdit doesn't implement it because JEdit is limited in how it does syntax highlighting, and I cannot make it work. I am bugging the JEdit developers about that right now, but realistically, JEdit has like 2 users, so it's probably going to take a while. ENSIME is editor agnostic. This is its most important feature right here. It's a subprocess. It's a subprocess that JEdit communicates with, using the same protocol that Emacs communicates with it, using the same protocol that the new Sublime Text ENSIME mode communicates with it. It's totally editor agnostic. And this means that all of this work that Eamon has been putting in, all of this effort that he's put in, we can reap the rewards of that in our editors, and it's practically free. Like, this is a gift-wrapped IDE for your editor. All you have to do is hook it up. It is multi-process and lightweight. So remember, I had this screenshot from earlier where I was showing Eclipse compared to JEdit. Well, this Java process here at the top is the ENSIME subprocess. Okay? This is the ENSIME subprocess, and it's taking up about as much memory as Eclipse did. Way less CPU, but about as much memory. Okay? So ENSIME hasn't really made this problem go away in terms of process architecture or anything like that. What it has done is it has moved the problem into a subprocess. So if I open up 5 projects inside of Eclipse, my memory usage will jump commensurate to those 5 projects. And it will be one process image. So I'll have one process image that's taking up 4 gigs of memory on my machine. Now, my machine has more than enough RAM to take care of that, but that's still a very large process image. If I do the same thing with ENSIME, I'll have 5 different processes, one for every project. And now that sounds wasteful at face value. But think about Chrome. Why is Chrome fast? It can't be because of memory, because Firefox actually uses less memory than Chrome does now. So what's going on here? Well, it's because Chrome is pushing this into subprocesses. Subprocesses are very, very, very lightweight. And modern operating systems are heavily optimized for managing subprocesses. They can page them out. They can page them back in. They can deal with them in parcel images. They can shuffle things around so much more easily than they can with giant monolithic things that are split up using threads. So this is super powerful. This is super, super helpful, and it makes my system that much more responsive. I regularly open up ENSIME, and I just fire up like 7 different instances of it. And it doesn't slow my machine down. It doesn't cause me any problems at all. This is super, super helpful. It doesn't slow down JEdit at all, because JEdit is a text editor that's a separate process. All of the communication with ENSIME is asynchronous. And so my text editing, which remember is the primary thing that I do, my text editing is not blocked waiting for the compiler to bless my source code. That is really, really, really valuable. Really, really, really valuable. So what are we giving up doing things this way? Well, we're reliant on the host editor for implementation. Okay? So poor Eamon slaves away on these lovely features, and people never see them because I don't implement them. And yeah, there's nothing that we can do about that, because ENSIME is a subprocess. ENSIME is a server. It's a server that you communicate with via a protocol. And Emacs provides a pretty complete implementation of ENSIME. JEdit doesn't. JEdit can't because of certain limitations. Sublime Text in its currently evolving ENSIME mode is still not complete. So there's work that has to be done on the editor side. But this work is surprisingly minimal. Okay? I've put probably, I don't know, 16 to 20 man-hours into the JEdit plugin for ENSIME. And it implements about 70 to 80% of ENSIME's functionality. It exposes that to users. 70 to 80% in 20 man-hours. Now that's including the time I took to reverse engineer the protocol. This talk, as well as the documentation that Eamon has now written, finally, should empower you to do that in half the time, maybe a third of the time. ENSIME is very, 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 very easy to work with. So what sort of clients do we have out there right now? It's editor agnostic. What editors implement this? Well, I basically already listed them. Emacs is the big one. This is the reference implementation. If you want to know how ENSIME does something, this is where you look. There's an inferior buffer you can pull up that gives the output of ENSIME. I never actually use it because I can never figure out how to work with Emacs. I reverse engineer ENSIME using Telnet like a boss. JEdit is the client that I've been working on. And this has like one user based on downloads on GitHub. And I think that was me. So there's, yeah, nobody uses that. But I find it useful, and it's enough that I maintain it. There's not a lot else that's complete right now. Sublime Text has a mode that's currently under active development, which is exciting, because a lot of people are using Sublime Text. So yeah, get ENSIME out to the masses. Mads Hartman has a very old ENSIME plugin for TextMate that I don't think even works with a recent version of ENSIME because the project initialization is different. I haven't actually tried it, though. And then there's like a really old JEdit mode that I tried working with that doesn't work. And then there's a Vim mode that's apparently in development. I don't know. For the most part, these things are still nascent. But they're developing quickly, right? There's a lot of interest in this. And I hope that this talk gives you the tools you need to pull up your editor extension API and implement it, because it's really easy. And it will make your life that much easier. It's worth investing this time. So how does ENSIME work? OK, what does the architecture look like? How do we talk to it? ENSIME is basically this. OK, it's a layer on top of a bunch of other projects. The Scala refactoring project. This is the same project that Eclipse uses to implement its refactoring. Scalariform, which is code formatting, a feature I didn't even list because I don't touch it. And then there's the Java debugger interface and things like this. All of this sits on top of the Scala presentation compiler, which is a different mode for the Scala compiler that makes things run fast by basically skipping a whole bunch of stuff. It doesn't emit code. It doesn't check things like overriding or higher kinds or anything like that. Basically, the presentation compiler catches as many errors as it can in 1.5 seconds and then stops. It's not exactly like that, but you kind of get the idea. More importantly, it gives a very incrementally updated AST. So the whole concept for this was developed by Martin Odersky and Miles Sabin in the 2.8 stream to support the new version of the Eclipse IDE. So this is what the Eclipse IDE uses. It's what NetBeans uses. The IntelliJ guys have their own foreign planet that they live on. And they kind of have their own thing. But it's basically their version of the presentation compiler. And additionally, we have Eclipse JDT, which lives under here. And this is because class path management is a pain. And there's really no need for Eamon to rewrite all of that code. Eclipse is an extremely modular project. It's very easy to pull out things like this. So the Eclipse JDT sub-project, basically the parts of it that are useful for running in headless mode, live inside of ENSIME. This is also how ENSIME has Java support. So you can actually run it on Java files. Was that what you were going to say?
Yeah, the error checking on Java.
Yeah. That's not supported in JEdit, but it is supported in Emacs. So if you open up Java files that are in your ENSIME projects, yeah, you have an IDE, which is pretty cool. So how do we work with ENSIME? If you are an implementer trying to implement ENSIME support in your editor, how do you do it? You spawn the sub-process. There's a batch script and a bash script inside of the ENSIME directory that you can launch ENSIME as a server. That's the easy part. When you launch it, you give it a file. This is a file that you select. It's a temp file or something. Just throw it somewhere. And ENSIME, when it starts up, it will choose a socket port, something that's available on your system, and write that port out as a number, as an ASCII number, into that file. So what you want to do is you probably want to busy wait on that file or something like that. Just hang on until a port is written into it, at which point you connect to it. You connect to that port, and it's literally just a raw socket. And then you can throw the file away or whatever. It doesn't matter. This is usually very, very quick. ENSIME starts remarkably fast. Once you have this socket set up, you send S expressions over the socket encoded via the SWANK protocol. Now, an S expression is a Lisp list. So this is the whole parentheses thing. This is the foundation of Lisp syntax. And this protocol makes a lot of sense because ENSIME started for supporting Emacs. It was very much inspired by Slime, which uses SWANK. This is not an annoying protocol to work with. A lot of people have talked about, like, well, shouldn't ENSIME be using JSON or something like that to send things around? No, this is not a problem. It's very, very easy to work with. And it's very, very valuable to be using the same protocol as Emacs. So I highly recommend you work with this. SWANK is easy, and I will explain how to do it in a second. All of the RPC calls are asynchronous. This is super important. When you ask ENSIME to do something, it will get back to you later, if at all. Usually when it doesn't, that's a bug, but it will get back to you later via a separate call. So you just hold this socket open, and you send S expressions down it. And you can send multiple things at a time. ENSIME's going to queue them up using actors internally. And you don't block on it. Do not ever, ever, ever block. So one important feature that your editor is going to need to have ENSIME support is the ability to make these asynchronous calls, to be able to send things off and then receive asynchronous callbacks and handle them appropriately, to be able to preserve that state. With JEdit, all the plugins are written in Java, or in my case, Scala, so that's really, really easy to do. With Emacs, of course, Emacs is just built on that foundation. Some editors, like Vim, have a harder time of it, but I still think it's possible. So how does SWANK work? This is the part that is now documented that wasn't when I got started. And I literally spent about 8 hours in a telnet session sending random bits to ENSIME to see what it would do. So I came up with this. Well, this is actually Eamon's documentation, but here we go. What you do, the first thing that is sent for a SWANK packet, the SWANK message, is 6 ASCII bytes of hexadecimal encoded run length. Okay? So this is the number 17 in hexadecimal. Right here, for those of you who don't speak hex natively. Following that, you have that many bytes of S expression. So when you are writing a reader for this, what you want to do is you want to read 6 bytes from the socket channel. You want to decode them as hexadecimal, and then read that many bytes and parse that as an S expression. And the same thing goes for things that you send to ENSIME. So this is the entire SWANK protocol right here. And obviously, this run length encoding thing you could use with other textual contents. But S expressions are what we use. And they work remarkably well. What do these S expressions look like? Well, this is how you initialize a project. This is the very, very, very first thing you will send to an ENSIME instance when you start it up. You get 1 ENSIME instance per project. The project is kind of a global notion inside of ENSIME itself. So you start a new ENSIME subprocess per project. And this is the very first thing you send as soon as ENSIME is awake, right? As soon as you have that socket, you're just going to stuff this down the channel. And it's the Init Project SWANK call. Okay? The Init Project SWANK call takes a whole bunch of parameters that I have obviously elided for space. And this is things that you're mostly getting from the .enzyme file. .enzyme file is generated using an SBT plugin or your build tool or something like that. And it's going to have your dependency jars and your source paths and things like that. You're basically sending this to ENSIME en masse. And along with this call, okay, this is a pattern that you have in every SWANK call, is down at the end there. Notice there's a number at the very, very end of the S expression. This is the call ID. Remember, calls are asynchronous. So ENSIME needs a way to get back to you and tell you, hey, remember that call you made 7 minutes ago? I'm finally done refactoring. So that's how it will tell you that call number 1 is done. So the response that ENSIME gives you is something like this. Return, OK, good, no errors. Project name. Well, project name and source roots, this is kind of redundant now. I'm not sure why ENSIME is still doing it, because we already have this information in the .enzyme file. But this used to be important back when ENSIME did a whole bunch of introspection using SBT. And then back at the end there, notice that call ID, number 1. This is the call ID that we gave ENSIME when we said, hey, init the project. Now it's coming back to us, and it says, this is your response. It worked. And this response could take a very long time to happen. So you can't block waiting for this. You have to set up a callback. But there's more. ENSIME is going to tell me some other things, just as a result of this init project call. It's going to give me a background message that says I'm initializing the analyzer. It's going to give me an indexer ready message. It's going to give me a compiler ready message. These are the full S expressions that it's sending me. So these are global messages that ENSIME basically proactively is sending down the channel and telling me that these things are happening, right? This stuff is going on. And you need to be able to handle these. So ENSIME communicates with you, not always through callbacks, but sometimes with these global messages. This is how error checking works. So if you want to do type checking on a file, type check on save, what you do is inside your editor, you register a handler for the save action, right? And on the save action, you initiate a type check file call. a SWANK type check file call off to ENSIME. And ENSIME gets back to you instantly, and it says, great. OK, well, that doesn't actually tell you anything. It got back to you right away, way faster than it could have type checked it, because what it's doing then is it's running the presentation compiler, or it's running the Eclipse Java compiler in the background to find out what the errors are. And as soon as it finds an error in any file, as it's going through them one by one, it will tell you via one of these global messages. So as soon as it hits an error, it sends it off to you. And it's your job to associate that error, which will be in the form of an error message, a file name, a line number, and a column number. You have to, well, column span, actually. You have to associate that back to where you are in the file. And actually, no, it's not a line number. It's character offsets from the beginning of the file. So it's begin and end. My mistake. Anyway, you have to associate that back to where the error needs to be in the file so you can display that to the user. And you're just going to be getting these calls out of the blue. So you have to be ready at any time to handle an error message coming from ENSIME that says, error in this file displayed to user, please. Right? And you're going to get a whole bunch of these if you've got a bad user who's writing invalid source files. So what is the future of ENSIME look like? Good. First-class debugging has been kind of the main priority for a while now. And ENSIME, as I mentioned earlier, Eamon has been working on re-implementing the debugging, which used to be just like controlling a JDB subprocess. That was horrible. Re-implementing it on top of JNDI, which is the Java native debugging interface that basically every IDE under the sun is using. So this will give you things like call stack and current frames and local values and things like that. I'll giving you the full debugger functionality that you would normally expect from your IDE. You could get that inside of Emacs. And if I find the time, inside of JEdit. So this is pretty cool. This is like the one thing that people miss going to a pure text editor is being able to do this debugging. Source jar indexing, this is something that people always like in various IDEs, right? Where you can do things like look up the source of Java-lang string just by open type, that sort of thing. In-memory buffers. I thought I mentioned this in the limitation slide, but basically, because ENSIME is a subprocess, it works on files. It doesn't work on buffers. The buffer is the thing in the memory that may be not saved yet, right? It's something that you're editing at the current time. And this is sometimes annoying because a lot of times you want ENSIME functionality on a dirty buffer, something you haven't saved, something that doesn't peer to a file yet. So Emacs does some really dirty tricks to save files out when you ask for things like you're doing content assist, right? Type, dot, right? Your buffer's dirty. Emacs has to save it. JEdit actually has some really nice functionality that very elegantly solves this problem. And so, but it's a hack. And it would be much nicer if ENSIME were able to synchronize in-memory buffers back and forth. And that's on the horizon. Stability and performance, there's a lot of bugs in ENSIME, mostly inherited from the presentation compiler, which has a ridiculous number of bugs. And editors. OK, more editors. OK, Eamon has put a ridiculous amount of work into this. He's done work that we don't have to do now. We can take advantage of all of this in any editor. Any editor that is capable of spawning a subprocess and sending these asynchronous RPC calls, we can get advantage of IDE-like functionality. So crack open your editor's SDK. Do this. Make it work. This is all the tools you need. There's more information on Eamon's website. I have source code for the JEdit plugin and the ENSIME Sidekick stuff. The ENSIME Sidekick, the JEdit plugin, by the way, is written. I apologize. I didn't know the slides were going to be this slow. The ENSIME Sidekick is written entirely in Scala. And it has about, 60 to 70% of a full ENSIME client inside of, written in Scala. So you can very, very easily look at that for source implementation. So if anyone has any questions, we have 47 seconds left. Oh, we have 5 minutes? We have 5 minutes and 43 seconds. So does anybody have any questions? Why aren't the IDEs using ENSIME as backend? So there are downsides to using ENSIME, like I said, the in-memory buffer things and things like that. And when you're an IDE, generally you have a lot of infrastructure already in place for doing a lot of this stuff. A good example is the Eclipse plugin. So the Eclipse plugin the Eclipse plugin for Scala doesn't bundle a separate instance of Eclipse JDT. it uses Eclipse's JDT through some very evil mechanisms to get at that. NetBeans uses the NetBeans Java support. So the advantage to an IDE is that you've got these things that are fully integrated. So if you have an Eclipse project, for an Eclipse Scala project, that depends on an Eclipse Java project, you can use OpenType from within the Eclipse Scala project and open files inside of the Java project. You wouldn't be able to do that very easily if ENSIME were the back end. So there are things that you lose this way.
And just to be clear, Eclipse does a language engine.
Right. Yeah, so Eclipse is using the presentation compiler. NetBeans is using the presentation compiler for its Scala support. The difference is that Eclipse will first run the presentation compiler, and will be running the presentation compiler constantly, basically, to keep its ADT up to date, its AST up to date. But when you save a file in Eclipse, it will also run the official compiler. And so this is why there will be spurious errors that show up inside of ENSIME, or occasionally inside of NetBeans, particularly relating to path-dependent types and things like that, that you just won't get inside of Eclipse, because Eclipse immediately overrides those errors with the official compiler, which doesn't have those problems. So yeah, so some of the infrastructure is unified. Scala refactoring and Scalariform are also used by Eclipse. OK, Nerman is cutting me off. So if you have more questions later, see me afterwards. Thank you. Cool.